Okay, we're going to talk about lessons 301 to 342. Some of the questions I've received have to do with objects and um, the code this, like this dot, also update all. So we're going to talk about all of those things and some other things. So this first lesson, lesson 301, is showing us the spinning of a box. And we're making the box in the same way that we've made them before, which is look here at line 10. We're just going to the upper left corner from the center. Okay, so um, if we, what I'm going to do is I'm going to make this number up here step a very big number so that we can kind of freeze it. All right, so if I'm in the middle here and I go left by half the box and up by half the box, that's negative W over 2, negative H over 2. And then we go to the bottom right corner, which is WH, that's down here. Okay, let's bring this back down to where it was. And let's talk about the spin. So the angle is being increased by 0.01 radians each time. We see that in line 2. And then as we talked about with animation in the previous lessons, the combination that's always used for this like um, frame adjustment or kind of stop action is CMTID, that's the variable that's declared. Clear timeout is a built-in function which uses CMTID, but CMTID is defined here in line 14. And this is really the key to understanding animation. This just means call the function draw step every step seconds, and step is 100 milliseconds. So we're saying that every 100 milliseconds we're going to call the draw step function, and that's what's happening here. So she's asking, can you make it go faster? Well, the easiest way to do that is just decrease step. So if we decrease step to 50, well, it's going twice as fast as it was because now it's doing it every 50 milliseconds instead of every 100. If we make it 10, well, that's even faster because now we're doing everything every 10 milliseconds. Okay, next. This works the same way as the moving box. Every time it's told to draw step, it clears the screen, rotates, draws the box, and then says to do draw step again in a little while later. Okay, that's basically what we just said. What happens if you comment out the ClearRect? Well, let's try that. If I comment out the ClearRect, we're not getting any erasing. And since nothing's getting erased, all I'm seeing is the outline of the corners left there permanently, and it looks like a big donut. So the function of ClearRect is to erase the canvas. And another thing that's important to remember is that what's going on here with rotate in line 12 is that the whole canvas is being rotated. The whole canvas is being rotated. Try adding more boxes. Did it do what you expected? I like this version. It's like a solar system. Try changing the speed now. So all she's done here is manually add some boxes. And we see that in 12, 13, and 14, this manual addition of boxes. Now, you can probably predict that if you wanted to do 10, 20, 30, 100 boxes, this would be really tedious, but we're going to learn a shortcut for that. Stop for a sec, sit back and think about how you might create 3 moving boxes. Well, you'd need the x and y position of each, right? And the size of each, maybe the dx and dy velocity of each, and the angle. You could create variables x1, x2, x3, y1, y2, y3, dx1, etc. Getting painful, isn't it? So this is getting tedious, as I mentioned before. And so here's a way to do it. Now, this is your first exposure to something called object-oriented programming. And an object is really just a bunch of code that defines the variables and functions for a particular thing that you're trying to use. In this case, the thing is a box. The box has variables, and later on we're going to add functions to the box, but for now it just has variables. And so at this point, there's really no advantage in using an object, but when we create many objects, you're going to see how important this is. Okay, so let's look at um, the format of an object, and let's try to understand what this means, because we see this in lines 3 through 8, this.x, this.y, etc. All right, so what we're doing is we are creating a variable, and that's how objects work. Um, in the past, you've created variables, but what we're doing here is we're creating a variable, and we're giving it a new type that we've defined. We are the variables we're used to are like sometimes they're integers, sometimes they're strings, sometimes they're decimal numbers. But here we're defining our own variable type, and the variable type we're defining is the box object. So in order to use an object, you have to create an instance of it. Okay, so lines 2 through 9 contain all the characteristics of the box, but we don't actually have an existent box until we create it. That takes place in line 11. So we create the variable, and then we use StrokeRect, but notice how in line 12 what we're doing is we are accessing the variables or the bits of information that the box has defined. So b.x, b.y, b.size, b.size. Now, how does this work? Well, with new box 10, 10, 100 right here, those are parameters that get sent to line 2. So x is 10 now, y is 10, and size is 100. And all that this does is this says, well, the x that's being operated on in this little snippet of code equals the x that's been sent to us. The this.y, which is restricted only to this snippet of code, is set equal to the y that's been passed to us, and the same is also true with size. Notice, however, that this dot angle, this dot dx, and this dot dy don't use anything that's been passed. They just assign numbers that are restricted to this particular snippet of code. What's going on is new box 10, 10, 100 creates an object, then immediately calls the box function to set it up. Box then uses this.x to set a variable named x in the object to the x that was passed into the function. It does the same thing to set up all the other variables in our new box object. Once the object is created and set up, we set our variable b to that. Later, we can get at the x and y and other variables of our box using b.x, b.y, and so forth. Our box object is just a little bundle of variables that describe our box. It says where the box is, its velocity, dx and dy, how big it is, everything that it means to be a box. So remember, we're starting really simple here with our first object, but the objects will get more complex as we go on. We can even have box objects know how to draw themselves. Okay, so um, in the past few slides, what we were dealing with is we were dealing with stuff like this that I've highlighted. Stuff like that is just the information associated with an object. But now the new thing is we can also have functions associated with an object. And so instead of calling a function directly, we just call it within the object. And we see that here in line 15. See, line 15 here uses b1.stroke. Notice that b1 has been created. That's our new box object. But within b1, there is a stroke function, and we access it by doing b1.stroke. See how this dot stroke is set equal to a function, and that function calls StrokeRect to draw this box. Then later we create a box called b1 and tell it to draw itself with b1.stroke. It's pretty cool, isn't it? You know, I have a secret. I've been hiding something from you. Okay, we're going to skip quickly over the next few things just because um, what all she's going to do is explain what the C dot is about. And the reason she's doing that now is because look, C dot stroke rect, we're seeing this dot here. And that dot means that stroke rect is a function that must be defined in an object called C. So the whole time we've been doing Crunchzilla, we've actually been using objects, but the definitions and the, the code structures for those objects have been hidden from us just for convenience. Okay, so we're going to skip through that or through our explanation of that. The canvas object. Oh, and then lines two to three here. We're not going to use these now, but later on, like even at after the end of the year, if you guys wanted to create your own HTML pages that you could post on a website and you wanted to insert these JavaScript games in them, this is part of doing that. But we won't do that in the course. I'll just do that for those of you who are interested later on. Okay, so skipping ahead, skipping ahead. Okay, can you create a couple more boxes and have them draw themselves? For each one, you'll have to use new and stroke like we did for the box we called B1. Okay, so you should take a minute just to do that. Try to challenge yourself to get that done. If you want to pause the video, you can, and then resume when you've had a chance to test yourself. Okay, so that's pretty nice, but calling each box B1, B2, B3, or whatever is painful. So for example, if we had done, um, let's say this box here, if we had created a new one, you probably did this while you were, working on your own. I'm sure you had the idea of doing like a var B2 and then a var B3, right? But notice if you want 100 boxes, you'd have to do 100 different lines of code, and that's a pain. So here's going to be a shortcut. What I need is a list of boxes like this. Okay, so notice that we have the same box definition. That appears in lines 1 through 13. And then we're going to use something brand new called an array. Now we did some arrays actually in Python. So arrays aren't completely new to you, but this is the first time that we're doing them in JavaScript. There is a big new thing here. I'll explain it. The double brackets. So you see that double bracket thing, and we see that in line 15, creates what is called an array, which basically is a list that holds stuff. These lists can hold objects, numbers, whatever we want. So looking down here, if we look at lines 17 and 18, um, what we're doing is we're just adding new members to the array. So in line 15, we are creating an empty array. But then in line 17 and 18, we are creating new boxes. Where does that happen? In what I've highlighted, that's the step of creating each new box. But then when each new box gets created, how do we add it to the array? Well, that happens in .push. So with arrays, all you have to do is you take the array name, you do .push, and that simply adds a new member to the array. So when we do .push for the first time, well, the empty array now has one thing in it. And then we do .push the next time, the array with one thing now has two things, and so on. Okay, so notice how this is much more convenient than creating boxes in separate lines of code. All we have to do is once we have created the boxes in lines 17 and 18, and we have filled the array up, then we go down to lines 21 to 22 and we draw the boxes. We simply draw the boxes. When we do that, notice how we have boxes I dot stroke. This is how that's achieved. And notice this is a for loop, so um, this gets called several different times. And each time it does, it's using a different index. So boxes 0 dot stroke will draw the first thing in the list. Boxes 1 dot stroke will draw the second thing in the list. Boxes 2 dot stroke will draw the third thing in the list, and so on. So var boxes equals double bracket means create an empty list and call it boxes. Boxes.push adds something to the end of the list. Here we use it to add a new box. Because it is in a for loop that counts 0, 1, 2, we will add 3 boxes to the end of the list. Take a look at the second for loop. Boxes.length is the length of the list. Boxes 0 is the first box in the list. Boxes 1 the second, and so forth. So that second for loop goes through every box in the list and tells it to draw itself by calling boxes I.stroke. All right, that's basically what I just explained. Can you add some more boxes? All right, so this is a time for you to, again, just experiment a tiny bit, look at the code, see what determines the number of boxes, and then tweak that. So take a minute to do that. You can pause the video if you want, and then resume it. So far, we haven't really done that much that requires box objects, but let's go a step further. Let's make boxes that are animated and move. Okay, so take a look at this. What we're doing right here is we are not animating anything yet, but we have a new version of stroke. So let's take a look at how that works. Okay, so the box object definition hasn't changed, but what has changed is this part that I've highlighted. We use save and restore, which we've learned before. Save saves the canvas as it is. Then you can do whatever changes you want to the canvas. Restore restores the canvas to how it was before those things were done so that you can start fresh for the next object. Okay, so what we do is we draw the first box, and then we do restore so we can start fresh. Starting fresh means that 0, 0 is top left. And so that means that our translate will go to this center, the center of this box, and then I draw it, start fresh with restore. This is 0, 0 again right up here, and so on. So save and restore is being used here kind of like we used it with the trees. When you don't do save and restore, you get all kinds of messy things on your screen. Save and restore is just a way to juggle many different things on the canvas, making sure that you can start fresh for each one. Whenever a box is told to draw itself, we do that by moving to the center of the box, rotating around that center to match the angle of the box, and then draw the box around its center, kind of like what we did before for rotated boxes. Okay, so notice what we're doing here is we are getting to the center. Okay, we're getting to the center, and we do that because all we have to do is we go to negative this dot size divided by 2 and negative this dot size divided by 2. It's the same thing that we did before, where we were doing like negative w over 2, negative h over 2. All that means is go to the left and go up from where you are, and then draw the box. This is the way that we can draw a box around its center. The rotate over here, notice, is a random angle. And how do we know it's random? Well, because that is achieved in line 27. Math.random times 2 minus 1 gives you a random angle in radians, and it'll be a fractional angle. So this a then, which is a random variable, this a gets passed to the function right here in line 1. And in line 1, a is a parameter. And then we have this dot angle equals a. So this is another example of what this means. Okay, notice that the function box is getting called 5 different times because we are creating 5 different box objects. How do we know that? In line 26, for var I equals 1, I is less than 6 means that we have 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. We don't have 6 because 6 is not less than 6. So line 26 here tells us that we are doing this 5 times. In line 28, notice that we have new box, and so a new box is being created 5 times. That A is a parameter that goes up here to line 1 each time. And since each time we call the box function, we are starting fresh, okay? And since each one of these 5 boxes is associated with a different variable, and that variable would be the boxes variable. Um, we have, right now, if I'm looking at this box that I'm hovering the mouse arrow over, this would be boxes 0. The next one is boxes 1. Actually, sorry. This would be, so yeah, boxes 0, boxes 1, boxes 2, boxes 3, boxes 4. And we see that right here. Notice it says for var I equals 0, I is less than boxes dot length, I equals I plus 1. And so boxes 0 then would be the first box. Boxes 1 is the second box. Boxes 2 is the third box. Boxes 3 is the fourth box, and boxes 5 is the the fifth box. And boxes 4 is the fifth box. Okay, because 0 through 4 is boxes 1 through 5. Remember, the count begins at 0 when you're doing the index of an array. Now let's make the boxes spin. Look at the new function update all. See what it's doing. Okay, so update all is simply the thing that's being called every 50 milliseconds. We have here the time step that tells us that it's every 50 milliseconds. We have the same format for the other animations we've done, CMTID, and then down here we see clear timeout and CMTID. Same deal. All we're doing is we're calling the update all function every 15 milliseconds. And what does the update all function do? Well, in line 8, it erases the canvas. In lines 9 through 11, it creates or it changes the angle of the box, and it also draws the box. And then what we have in lines 18 through 22, that is the creation of boxes that we've already seen in the previous ones. Okay, so notice that the creation of the boxes is not inside any function at all. This is just part of the main program. So of course lines 1 through 5 get executed first, but then lines 18 through 22 get executed next because they're not within a function. Lines of code within a function are dependent on whether that function is called, and that doesn't happen until line 24. So the function call in line 24 is where the updates are made. And notice this is the beauty of having box objects, is we can do all of these updates, and we can do them once every 50 milliseconds because we're using arrays for our boxes. It saves the amount of code we have to write. It saves us time. And all of this is using the same box definition that we've already talked about before. That hasn't changed. All that's changed is we are doing updates of those 5 boxes. And we're doing 5 updates every 50 milliseconds. Now that's not much time, but computers are very fast, and so it can easily handle this. We can even make the time step 10, and so everything's going faster because the updates are happening more times per second. Update all starts by clearing the screen, then rotates each box a little more before drawing it. Finally, it says, call me again in 1/20th of a second. So 20 times a second, we rotate each box a little and redraw it. Cool, huh? Can you make the boxes spin faster? Well, I kind of already did that for you by changing the time step to 10. But we can also do it by messing with rotate speed. Let's say instead of point .02, we make our rotate speed 0.2. Well, now we're getting crazy speed. And we're getting crazy speed because every time it updates, it's increasing the angle in radians, not by 0.02, but by zero point 0.2. So that's 10 times as much. All right. Can you make them spin the other direction, counterclockwise instead of clockwise? Well, I think you can pretty quickly figure that out, but I'll give you a second to do it on your own. So pause the video and then resume when you've had a chance to do that. Okay, so you probably saw that it's going to be right here in line 10. Instead of plus equals, we're going to make it minus equals. So now we are subtracting 0.02 radians from each angle instead of adding. Can you add more boxes? You'll have to change 3 things to fit them all on the canvas, but I bet you can figure it out. I liked it with 60 of them. It looks really weird. All right, so yeah, pause the video, try and do that on your own, and then resume when you've had a chance to do it. Okay, so let's see. What if we wanted to increase this to 15 boxes? Okay, because right now we have 5 boxes. If we wanted to do 15 boxes, we change this. All right, that's 15 boxes, but they don't fit on the canvas. Why? Because every time we are moving a box to its new location, we're doing I times 50. So 1 times 50, 2 times 50, 3 times 50, 4 times 50, etc. If we don't want to move over to the right as much, well, we need to simply change this number. So let's see, what if we change it to 20? Well, that works, but it's still going off the bottom of the canvas. That means we also have to change this number because this number affects how much it goes down each time. So let's say I change that to 10. Well, now what we have is we have all 15 boxes fitting on the canvas. All of those fast spinning boxes make me dizzy. Let's slow it down again and let me show you something else. We can move the update into each box object. That will be handy when we make the update do more. See what this does now? So really it does the same thing. The only difference um, is that we have changed where the update thing goes. So look, in line 10, we're calling the boxes.update function. To see what that does, we need to simply go down to this line here, or these lines, 33 to 36. We have created within the box object a function called update. So it will update every time for each box created, and it will do that every 50 milliseconds, as we can see in line 2. So really all this is doing is for convenience, it's moving the update function into the box object. Update all just calls the update of the box. Update on the box changes the angle and then draws the box. Each box knows how to update and draw itself now. Let's make the boxes move too. All we have to do is have update use dx and dy. Take a look at box and how it is updated now. Okay, so box is still receiving parameters, but notice that we also have these parameters, dx, dy, dA. dx means difference in x, so difference in x coordinate. dy means difference in y, that is difference in y coordinate. And dA means difference in angle, so difference in how much the angle changes each time. Now, if we look down here at how things are defined, Notice how what we're doing is we are introducing a lot of randomness in lines 58 through 63. And we are making everything random, where it's positioned, how fast it goes horizontally and vertically, um, what the initial angle is, that's line 60, how much the angle changes each time, that's line 63. And then in line 64, we simply add that new box to the array. Okay, so this is pretty cool because we can do a lot of different boxes, and each box is independent of the others. Now, let's take a look at how the bouncing happens. It's a little more complicated, but only a little. Every time a box is told to update, it moves by its velocity, dx and dy, and rotates by its angular velocity. If a box gets off the edge of the screen, we reverse its velocities, making it appear to bounce. Now, we saw some bouncing when we were doing Python. You guys might remember how when we did the bat and ball game, we had bouncing happening off the walls or off the paddles. And this is the same thing here, okay? Because with the bouncing, we say, well, if this dot x is less than 0, or this dot x plus this dot size is greater than w, all this translates to, you could say this in other words, if this dot x is less than 0 means that it's too far left. And then over here, this dot x plus this dot size greater than w means it's too far right. When that is true, it's time to bounce. And so here's the bounce. This dot x equals negative this dot x. So if it was going right, it's now going left. If it was going left, it's now going right. And then look at this over here too. This dot dA equals negative this dot dA. If it was going clockwise, it's now counterclockwise. If it was going counterclockwise, it's now clockwise. It simply reverses it. Let's take a moment to watch a bounce. See this bounce up here? It hit the top and then reversed. Okay, let's watch this bounce over here. This one's a little bit faster. So right now I'm hovering over a box. I'm hovering over a box. Watch what it does when it hits the left wall. Boing, right? It hit the left wall and then its orientation of spin also changed, simulating what would happen if a spinning object hit a real wall. All right, everything else is pretty much the same. We are using an array. We are pushing new elements into the array. We've got a box object that has all of the functionality built into it. Okay, the bouncing functionality, the ability to draw and update itself. All of that is built into the box object. This is the beauty and necessity of using objects. It allows us to do identical things that have slight variations and to do them for many objects on the same canvas and to do that many times per second. So objects are really key to doing any type of complicated animation. And we're seeing a little bit of that right now in Code Maven, and we'll see a lot of that in Game Maven, where we'll be using animation to create games. All right, well, that's it for lessons 301 to 342. I'll post the new assignment as well. And you're welcome to add or you're welcome to post any other questions you may have. We're not going to have the next test until the end of lesson 380. And 380 will be the end of Code Maven, at which point we can go on to Game Maven.